Hello friends, today I am back with graphs part 2. So, in this I'll be teaching you all about computer representation of graph. So, there are three main types of computer representation of graphs. Those are adjacency matrix, incidence matrix and adjacency list. First let's see what's this adjacency list. In this, representation graph can be represented using a matrix of size total number of vertices by total number of vertices. That means if graph is with 4 vertices, then it can be represented by 4 by 4 matrix class. In this, both rows and columns represents vertices. The matrix is filled with 1 or 0. 1 represents edge from row vertex to column vertex and 0 represents no edge from row vertex to column vertex. This theory part will be better understood with the example which I'll be teaching in the next slide. So, this is the example for this. Here the graph is given A, B, C, D, E. AB is 1 vertex, BE is 1, DE is 1, D to A is having 1 edge, A to C is having 1 edge, C to D is having 1 edge, and there is a self loop for D. Now, how we can represent this? What was the thing I explained you in the last point? That is, how many number of vertices we have, that many number of rows and columns will be in matrix form. Now here A, B, C, D, E. There are 5. So 5 elements, that is 5 nodes. So 5 by 5 matrix will be there. And when we use 1, when there is a directed representation, and when we use 0 is when there is no edge, no path, no directed path for that. So now here in the matrix A to A is given. So is there anything over here for A to A? No, there is no self loop, it's also. So that will be 0. Then A to B. A to B we have the directed edge. So we'll be writing it 1. Then A to C. We have it again. So again 1. Then A to D. A to D we have the path. We have the edge. But it's in different direction. It's for D to A, not for A to D. So it will be 0 for A to D. Then A to E. A to E is there is no chance of the edge itself. So it will be 0. Then B to A. As the arrow is in different direction, it's not from B to A. It will be 0. Then B to B, 0. There is no loop. Then B to C. B to C is also of no chance. So 0. Then B to D. B to D, here it's going in this direction. So B to D is 1. Then B to E. B to E is also a edge. So it's again 1. As it is a directed edge, we have to take care that we just see only the directed edge. Then C to A. C to A we have the thing, but it has to be. So C to A we have the direction, but the thing is it's in different direction. So it has to be again in 0. Then C to B. C to B there is no chance. So it has to be 0. Then C to C no self loop, 0. C to D, yes, we have the arrow. That is we have the path. So C to D is 1. Then C to E there is again no chance. So 0. Then D to A. D to A, yes. Now we are having the edge from here to here. So this is 1. Then D to B. D to B also there's an edge, but it's in the different direction. So it has to be 0. Then D to C. D to C we have this, but it's in opposite direction. So again it has to be 0. Then D to D. Yes. Now here we have this self loop. So it has to be written 1 over here. Then D to E. Yes, D to E also there's a edge. So D to E will be 1. Now E to A, E to B, E to C, E to D, E to E. These are all, they don't have any connections. Yes, of course we have for B to D, but those are in the different direction. So it has to be again 0. So for this whole everything will be 0, as there is no connection from E to any other elements, that is any another nodes. So it has to be 0. Hence, this is the given graph and which is represented in the adjacency matrix form. So, let's see the next representation now. That is incidence matrix. In this, graph can be represented using a matrix of size total number of vertices by total number of edges. That means if a graph is within vertices of 6 edges can be represented using a matrix of 4 by 6 class. In this, rows represent the vertices and columns represents the edges. This matrix is filled with either 0, 1 or -1. When the 0 is represented when row edge is not connected to common vertex. 1 it's represented when row edge is connected as outgoing edge to column vertex. And -1 row edge is connected as incoming edge to column vertex. So this theory part is better understood in the example which I'll be showing in the next slide. So let's see. Now here A, B, C, D, E. And we have the edges named as E1, E2, E3, E4, E5, 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 E6, E7, E8. So when we represent 0 when there is no path, and if there is a path then we represent 1, and if it is in the opposite direction then we represent it as -1. So now A to even. Now here we have written the nodes and here we have written the edges name. So now A with even is it's going in proper direction. So 1. A with E2. What's this E2? E2 is in this direction. So again it's 1. A with E3. A with E3 it's possible, but here it is not going from A actually. It's coming from D. So it has to be -1. As the path is there but the direction is not proper, then at that situation we use -1. Then A to E4. A to E4 there is no chance. So it has to be 0. Then A to E5. Again there is no chance, so it has to be 0. A to E6. No chance, so 0. A to E7. No chance, 0. A to E8. No chance, again 0. Then B to even. B to even. What happens over here? From A it's coming, not from B it's going. So we have to write here -1. Then B to E2. B to E2 again there's no chance for that. So it has to be 0. Then B to E3 it will be 0 as there is no way for that. Then B to E4. So what's this? B to E4? Yes, it's going from B itself. So it has to be 1. Then B to E5. B to E5. No, there's no chance. So it has to be 0. B to E6. It has to be 1 as, B to E6. Yes. B to E6. There's a chance for that. So it has to be written 1. Then again for B to E7 and B to 8, it has no chance for going. So it has to be 0. Then C to even. C to even there's no chance. So again it has to be 0. Then C to E2, it has to be C to E2. Yes, it's in opposite direction. So -1. C to E3. C to E3, it has to be again 0. C to E4, it has to be 0. No way for that. Then C to E5. C to E5, yes, it's going for D. So it has to be 1 for this. Then C to E6. C to E6, is there any chance for that? No. For E7 also there's no chance, and for E8 also there's no chance, so it has to be 0. Then D to even and D to E2 has no chance of path, so it has to be 0, 0. Then D to E3, yes, there's a possibility as it goes to A, so it has to be 1. Then D to E4 will be -1 and D to E5 will be -1 as there's the opposite direction of those. Then E6, E7, E8 for D will be 0. E6, E7 it will be 0, and for E8 it will be 1 as it is having a self loop of it. So it has to be 1. Then last is E. As it has no other nodes further or no any other nodes it's sending the edge, it has to be every rest thing should be 0. But the thing for this is there's a path coming from B to D. So that is E6 and E7. So it has to be -1. So only E to E6 and E to E7 will be -1. Rest all will be 0. This was all about This was all about incidence matrix. So now we'll move on to the adjacency list. In this representation, every vertex of graph contains list of its adjacent vertices. Now here the graph is A, B, C, D, E. So what we do is, here we keep on adding a list for those when there's a connection. So for A there's a connection with B, and for B there's a connection with E, and we have made it like this. Then for B there's a connection for D, and D to E there's a connection. So this has to be made in this way. For C there's a connection between D, and there's a self loop. So no again further loops will be added, further list will be added, sorry, okay. Then for that there will be only C to D connection. Then D has connection for E, D and A. So what happens is, it's going for A, then we can go for D, and then we can go for E. So this was all about adjacency list. We can just add it like the list, the same way in which we added linked list and those sort of thing. So this computer representation of graph has three types. One is adjacency matrix, incidence matrix, and adjacency list. I hope you all have understood this concepts, that is various types of representation of graph very well. So if you have liked my video, please hit the like button. Thank you so much for watching my video.